Hmm, very interesting. Maybe we should catch it right now. Waiting for the rest to join as we get to start. Waiting for the rest to join as we get to start. waiting for the rest to join as we get to start. I'm seeing some others are joining right now, so I'm waiting for you to join quickly. You can as well look on the chat section where you can raise your questions and answers, and I'll be able to respond. You can comment, etc. Now, I would like to begin once again because, in the interest of time, we'll go straight away to our lecture today. And as I said before, that it's very important for you to understand what engineering drawing is all about. As I said there before, that before machines are built, before circuits are manufactured, before aircraft take flight, or even biomedical devices are produced, they all begin the same way as drawings. So drawings communicate ideas, shapes dimensions, and functions clearly so that engineers around the world can understand exactly the same thing. So this semester we'll be using a new teaching approach combined of virtual learning and physical classroom practice to help you master this language effectively. So during our physical classes, we'll be focusing on manual drafting. Okay, you draft or you develop the essential skills of sketching, constructing, and understanding drawings using traditional instruments. This is extremely important because manual drafting trains the mind to visualize objects, proportions, and geometry accurately. So during our virtual sessions like the one you are watching right now, we will take advantage of engineering design software such as Autodesk Inventor, which I have already here, up and running, and similar tools. So the tool allows us to demonstrate 3D models, projections, and transformations in ways that are sometimes difficult to visualize using only flat drawing sheets or, in layman language, 2D, two dimensions. Okay. Now, for example, when we study projections, particularly isometric and orthographic projection, of which we're going to start after this introduction, the ability to rotate 3D model and observe it from a different direction helps to internalize the concept much faster. So the object of this blended approach is simple: to help you develop strong visualization skills and the ability to see all three-dimensional object in your mind and represent its accuracy on a two-dimensional drawing. That would be manual drafting. So this case is a fundamental not only for mechanical engineers or just biomedical students or electrical students, but also for those who are working in various streams in robotics and many other fields of engineering. Okay. Now, throughout this course, as we will start, you will learn how engineers communicate ideas using drawings, how objects are represented using objects, and how complex shapes can be constructed step by step using schematic methods. Now, during these live sessions, feel free to ask a question through the chat and comment section, especially if something is not clear. Engineering drawing becomes easier when we interact and discuss concepts together. So later during the physical practical sessions, you'll apply the same concepts manually so that both conceptual understanding and practical drafting skills grow together. So I encourage you to approach this course with curiosity and patience as you get to learn more and more. But by the end of the semester, you should be able to confidently read, interpret, and produce engineering drawings, a skill that will support you throughout your engineering career. And once again, welcome to the course and welcome to this semester as we proceed. Let us begin by exploring one of the most fundamental ideas in engineering graphics, which is known as projection, and understanding how engineers represent three-dimensional object on two-dimensional planes. So I will proceed, and I would want to know your comments as we proceed. I'll check them out so that at least we don't get dragged behind. Yes, remember there's a chat section that you always hear. You can always do what you can watch also my cursor as I get to demonstrate and as I go to teach. So in this section, you can chat with me, raise some questions, and I'll respond, especially towards the end of this section and lecture. Okay, back again to our presentation, which is all about engineering drawing. Okay, now, as I've just said again, people express their thoughts in so many ways. Over years and ages and decades, engineering drawing has been there, but mostly people don't understand even what we get to see nature, how it can be conveyed to us. Some other people are artisans. The artist, so many as in they get to draw nature, etc., drawings, etc. But in the most important thing today, I'm gonna go straight away into our topic for today, and that would be about isometric. But before I get to introduce isometric, again, I want to touch base on what we've covered previously. And for those who are new in engineering drawing, you will realize that there are typical branches of engineering drawing. Okay, and once you get to understand them, then you'll be in a position to move forward. Drawing is applicable in manufacturing, in power generation, in transportation, power system, in atomic energy, marine vessels. Those are typically branches of engineering drawing. Now, not only to not to forget about aerodynamics, structure. We talked about biomedical and electrical as well as many others. Okay. Now, today we want to understand why or where is the applicability of engineering drawing. I had explained it in our introduction, chapter there before, but you very well know that engineering drawing is just applicable in the design of some new products, as it can be illustrated here. Okay, it helps one to understand, internalize, and visualize, especially when you're using 3D. Okay, drawing can help you to do presentations and also community projects, among many other things. And then before we said when we are using manual drafting, of which we're gonna do in our practical lessons, you know very well there are quite a number of drawing equipment, especially wherever you are right now. You know what we call a drafting equipment, which include a drawing board, T-square, drafters, French curves, which are French curves, among others, and also these are the French curves, uh, uh, among other items. Okay, now those are the tools, and especially you know about the pair of crumbles, a drop burr, which is used and where they're applicable. That one we've done in our introduction lessons, etc., etc. These are also curves, French curves that are dimensions, which can be used in irregular and regular shapes to aid in quick drawing and documentation. And as I scroll through, you know very well, we talked about stencils, which are very important. Pencils, they're of different types, especially those ones which are used to draw various types of lines. We had discussed about this one. And as we proceed today in our lecture, we'll just encounter some of those applications of stencils and where they're widely used to draw hidden lines, outlines, among others, etc., etc. Now, today, our lesson is all about isometric drawings, as in the design process. But before we get to understand what isometric drawing is all about, then I need to bring the concept of where it originates from, where it emanates from. Isometric is just a branch of projection, and projection is just a drawing of an object formed on a plane. Okay, for example, you are drawing your manual drafting in your first semester. You came across where we would draw specific objects. In this case, let me talk about a frustum that was examined in the exam. Uh, you realize that you need to draw it in an object. The paper basically became like a plane where you were just drawing it. So it was in 3D, but the actual surface was just a plane. We'll talk much, and I will demonstrate about in 3D what a plane is all about later. So basically, isometric is represented in 3 dimension or represent 3 dimension objects on a 2 dimension surface. Very important to know about that one. And I'll just go straight away to the overview so that you understand. Basically, in projection, we have planar geometry projections, which is divided into two categories, parallel and perspective, whereby under parallel, it's also subdivided into two sub-domains, orthographic and oblique. In orthographic is where we have what we call axonometric and also what we call isometric, among others. So you understand where this emanates or originates from. So when I trace it up after isometric, we just go to orthographic views and back to other types of views, parallel, etc., etc. That's when we get to do with assembly. Beautiful. So I don't want to go much about the engineering process and many other things, but I want to exactly speak about the steps usually in engineering design and process, which is basically what you do in manual drafting. First and foremost, you've got to understand the problem at hand and you formulate it. Formulation, you can just go do it by sketches, etc., etc. You develop models, and from those models, you can implement now the design. And note that at the end of the practice or just our lectures, we'll just also have what we call a practical uh, design of the same, etc. But still, in our example, you'll be experiencing this. Okay, let's proceed. Now, what is a design? You elaborated there before what a design all entails. And today, I would like to say that is a design just is basically a process of conceiving or just inventing ideas. What are ideas? You've got this kind of crazy idea, like you are a biomedical student and you want to design maybe an implant, and this crazy idea you've conceived, you've got to bring it to fruition, and then therefore you've got to start by brainstorming. You've brainstormed. You have to bring it to the from brainstorming and concept development to the actual sketches of what you perceive or you've internalized. And from that perspective, you bring in the design function and purpose. And then now, that is it. That is it. You produce through drawing. It is a process. Now, let me go to our help list so that you can understand what is isometric sketching. In today's goals, they're just for three. We're going to learn on and understand the process of creating isometric drawing, learn the process of sketching ellipses in isometric drawing, and develop the ability to visualize objects in 3D, in 3D or three dimensions. Pay attention when I'm talking about ellipses. We had learned about them last semester. Okay, and I want to believe very well that you were examined and you came across what you call isometric ellipses. But today we'll just demonstrate them, how they're being done. You visualize, you internalize, and you understand it, each and every step that we want to take. Now, it becomes interesting here. How do you make an isometric sketch? You remember very well we talked about an angle, which we call an isometric axis. Assuming you are doing on a vertical line, as I get to hover over here, you can see at an horizontal line parallel to the edge of the paper, hypothetically in a 2D when you are drafting manually. So isometric sketches, they usually use three principal axes, okay, which is 1, 2, and 3. And height, width, and depth. Accurate axis construct help maintain proportional geometry. Pay attention to what I'm just saying again. Accurate axis, accurate axis. For example, if you draw this line not accurately, then definitely this angle will change because we need to have both of these angles equal, and therefore the interior two angles will be equivalent to 120 degrees, 60, 60. But this is not exactly 30 degrees, then it means the other side won't be 30 degrees, and therefore it won't give you an accurate sketch of an isometric drawing. Now, today will be very interesting because I'll be using 3D to explain about that one. But before we come to using the software to demonstrate for your understanding, I want you to understand the conventions of sketching an isometric drawing. Okay? As I just said again, it follows just a standard axis orientation. The height, the depth, and the width. Depending on the point of view, this one can be also a width, and the other one can be also the depth. Okay? These axes guide the construction of 3D objects in isometric form. Remember, isometric drawings are in 3 dimensions. Now, voila, we have a practical example here of a 3D object. And the question here is, if you were to draw this one, how would you have drawn this sketch? How would you have sketched it? So today we're gonna practice one-on-one, not practically but theoretically through 3D demonstrations for your understanding on how we can do such a design or sketch such a drawing. Beautiful. Now let's practice by using this simple geometric object here. And one thing I want you is to focus on maintaining the correct proportions and alignment as I'm gonna demonstrate. The third thing you need to note is just to identify the visible edges. These are visible edges. Like for example, depending on the point of view, this one, that one, this one, that one, and that one, and this one, they are all just edges, visible edges. Okay, depending on the point of view, we'll come to that one, the next step. Now, what are the processes? One, blocking the object. This is the object. I've talked about a plane. For you to be able to understand on how to sketch this kind of isometric drawing here, okay, we begin with the front face, facing it from the side of the arrow, as you can just see. Very important. Pay attention to this. This becomes the basic bounding box of the object. Also, pay attention. It's not cast on stone that this has to always to be the front view. But for today, we are viewing it, we are taking this side as the front view. Because also from this side can be taken or regarded as a front view. Okay, or front face. We'll talk about those ones later. Now, the front box here that has been is displayed in green and also blue establishes the overall dimension from the base to the top and all the edges. It helps maintain the correct proportional and proportions and orientations. Let me just use a 3D object, for example, here. The software is Inventor. This is Inventor 2025. Now, for your information, I've just drawn is not exactly the same, but I want to illustrate what we're just talking about. I will just click to highlight. For example, this side, I want to select the faces that are visible. This side, this face, and this face, and this face, and this face, and also this face, and also this face. If you view it from this side, pay attention to the axis. From where? From the front side here. Let me just click on this and drag. That's what you see. If it were in front of you, that's what I call a face. Now, when I'm talking about the overall dimension, I'm talking about from this base to the maximum height, cutting across to the other end, and downwards to this edge. So that's what I call the overall box. If you were to view it from this direction. Now, let me go back to our drawing back again. This is what I meant. The several faces here. For example, in this case, we have this face, and 2, and 3, and the interior one, which is cut. We are moving on together. Good. Now let's proceed. I'll go back again to the drawing. I've said the first step is just to the blocking the object. In this case, we begin with the front face. Now, the second step is blocking the object by adding the side face. We have worked from, or we have understood what the front face is in this case. Now, this is the side face. It's also demonstrated in green or color. We call it the side face or a view or side view. We'll later explain, I'll just illustrate to you later the types of views and what they're applicable. Okay, but now let me use a simple terminology, a face. Okay, now in this case, we're going to add now the side surface of the object within the bounding box. Again, let me use our 3D object. Now, I will just click here to deselect. Now, we are viewing it from this side in this case, and it's not the same, but it's similar, almost the same. But what will you, if it were from the right side? Okay, that's the right side exactly. What will you just see? You just this kind of overall length, this overall length, this overall length, this overall length, downwards, exactly as I'm just hovering over that. Okay, let me for your view, let me just zoom so that at least you are able to view it perfectly. Again, in front. Let me just go back to how it was isometrically drawn. Later, I will demonstrate on how it is being drawn. It's very easy to show that one. I'll do a few tricks here for your understanding. But for today, we want to visualize about the faces. The overall length is when it's you're assuming that you're viewing it from this side. In this case, when we go back to our presentation, you realize I'm talking about this face, the overall length. In this case, we'll talk about what? If it was an axis, we'll just be talking about this length and this length overall. There's a box, okay? And that's why we'll get our side face. So in your work, you must ensure that the edges follow the isometric axis directions. In this case, like they are parallel. And this one thing, usually for the beginners, have a challenge and a problem, especially in dimensioning, an isometric drawing. I noted and I've noted in my many years of experience that most of the students tend not to draw parallel dimension lines like it is illustrated here. Let me just expand this so at least it's visible. Okay, and let me just perfectly align that one. Yes. Now, it's very important to understand this. Parallel lines should be parallel to the edges. Now, the next step is adding the top face. We are still in blocking in the object. We are blocking in. We started by the front. We came to the side. Now we are coming to the top face. And it's becoming a block. That's what I meant by blocking in the object. Now, three dimensions. The first dimension, the front. The second dimension, the side face. The third dimension is the top face. So to draw the top plane of the object, we use the same symbol guidelines. And we ensure that all the edges remain parallel to the isometric. Now let me go to our Autodesk Inventor, and this is the plan. You are viewing it from the plan. If you are to view from the plan, let me just click here just to show you how it would look like. So if you were to do the plan, the overall, block it the entire face, what would you just have? You would have this entire length up to there, downwards up to this edge, and further without these curves. We'll talk about them later and how they arrive if you were to draw orthographic views. Okay, we go back again. So this what you are able to see this face. Let me select it. That one, that face, this face, the other side, this bottom, and also what have I left out? That one. And also do not forget about this one and also this one because they are visible from the plan. Okay. And again, let me click on the top view. That's what you'll be able to view. However, now when you're blocking, you have to draw the overall dimension without this straight without before the curved, the edges are curved. Okay. That gives you the overall length. Back again to our demonstration. Okay. And for those also who are viewing, please ensure that in the chat section, you just in your admission number, registration number as part of the attendance. I'll check it out later. As you get to raise your question, also start with your registration, not name, but registration only is sufficient enough to identify. Yeah. Repeat again. In question, start with in the chat box with your registration number and raise the question. and I will address it. And also for attendance purpose, in the chat section also, make sure you've entered your or typed in your registration number in the comment section. Thank you. Let's proceed. Now, the next stage after blocking the top or hiding the top face is the cutouts. Now, remember we've drawn the overall block before we get to carve or just create this kind of object as it is, as in what we call the cutouts. We now want to remove these faces or other edges so that we may retain the actual shape. Okay, we've blocked it out. This is it. Okay, now we're starting with the first cutout, part one. As you can see in the same block, I will just go to the entire the software, and again, allow me just to straight away illustrate in the software so that you may understand what I'm talking about, the cutout. Okay. Now I'm assuming that we're having a block. I don't know of whichever dimension. Let me assume. Okay. Let me take you back to the software. It's the presentation itself, and where we were. Let me talk about the height of. Let me say that it's a block. Let me talk of a height of let me say 70. In this one, maybe what can we give it? Let's give it 100, and the other one also let's give it as per the shape. Let me check on the shape. It can is done dimension, but dimensions are not here. Let me give this side like a hundred, like 100, and the height like 70, and this depth. Let me give it as what as 80. Okay, and let me use the software to demonstrate quickly. And before we go to cutouts, okay. In this case, I'll just start a new draft, a new drawing. I'll explain to you later how you get to do this. Okay, and thank you, because at least this will help us to understand views. Pay attention to this one, what we call views or faces. As it is, let me hover over this one. This was our front plane or face. I'm hovering so that it's visible. Pay attention to this one. It's very good to visualize this way. Now, if I hover to this one, this was our side view. And here below was our top face. If you move it to the top of the object, okay? Now I'm gonna select this face as the front face. And in this case, I'm going to start by drawing, as I just said, let me say even a rectangle. I can draw a rectangle method, but I can just use also even lines. So there are various ways in which we can draw. So in this case, I'm going to use a line just to draw quickly, and because we talked about the length and the width, etc., etc. Let me say it's the line just is horizontal, and I want to type in the length. We say that we want it the front face to be around length, the depth 80. Okay. Okay. Let me. Okay. I've already shown the dimension. And I'm gonna draw. Apology for that. I'm gonna draw. That's it. Now, just by showing you, this is 80. After I put it in 3D, but I want back again to sketching it in 2D. Okay. So that at least we can still continue in drawing. But before we proceed, I want you to understand what we are working on. I want to demonstrate on how these cutouts are done. These cutouts are done. Okay. Okay. So the first thing, it was the part one, not part three. The first cutout we want to work on is this side. The block is complete, but this face here, the cutout. So we have to identify the areas where the material is to be removed. We begin by marking. I have just marked here by considering the dimensions, assuming the height may be like 20, this one like 30, and the height may be 40, and remaining with this one 20, etc. And the overall length is as such. And when we move to the next Part 2 about the cutout, we have to consider the bottom one. Okay, now we've marked. Initially, we started by sketching, and pay attention when I always say the use of stencils, the application of pencils. Which kind are you? Do you use HB? Do you use 4H? Construction signs are drawn by the hardest stencil. The harder the stencil, the lighter it grows. And as such, as you can see, I've differentiated between the outline and also the construction line here for your understanding. The same way it's applicable in manual drafting, which is very key to us. So pay attention. Now let's go to the second step, which is the second part, cutout, part 2, the bottom one, this part. In the same way I've marked, the edges are visible here, but here they've been marked as construction lines with a different color for easy identification. Always ensure whether there are hidden areas, and those hidden areas are considered. Pay attention when it's in isometric view like this one. You cannot see the entire face from here until it's in front of you. Here is a good example. Let me just take you to this block. It's like, will you be able to see exactly this face? The way it's placed, no. Until it's exactly in front of you, it's when you'll be able to see this part. Okay, so consider the hidden parts. That's what I just meant in this case. I will take you back again. But also hidden features can illustrate different. For example, if you are from the plan, pay attention. This is a hole from here. In this top view, you can see these horizontal holes through it. But if I get to select, still you can see it. You can only see these holes that are directly in direct perspective to you eyesight. Now, let me just again go back to the home view and have an understanding of what we call the cutout that was in these. So that's what I meant, that you ensure that hidden areas are considered. Okay, there is the edge, the bottom one, etc. But this is the cutout, and we want to take it out. And the last part is this. Is the third part is this cutout. You see, after that we had blocked it, there is a way, maybe it's inclined at an angle. This can be joined all from here to here. The dimensions are given, and from here to here the dimensions are given. So you join and also draw parallel lines. Always parallel lines. If they are isometric lines, they should be parallel. The edges, this one to that one and that one. So you can get this cut out. So you've got to refine the intersections and the edges, and then you prepare for the final drawings. That's why I say always use the latest stencil construction line to draw construction lines for you darken the edges. Now this is the final product. As you can see, we've plotted and we've plotted out the cutouts, and now we want to remove all the cutouts, the unnecessary parts that we don't want, and then we remain with our object. So that's how an isometric drawing is done. And in that case, we go to the final water, darkening the final edges here. In this case, the edges have been darkened, and it shouldn't be part 3, it should be part 4. Okay, in this case, let me change it. Now, what you can see here is that the edges have been darkened now. All the edges have been darkened, and the rest are written as what? Construction lines. Always start with construction lines, whatever, when you're working with isometric drawings, and then let the final solution be only darkened using HB or the latest stencil that is recommendable is HB, which is the better option in manual drafting. But here in the software like Autodesk Inventor, I can use thicken the lines using the software. It's not a big thing. Now, let's move to the next step. And this is where we have had a challenge for most beginners: isometric ellipses. In our previous class, when we were discussing, and I repeat again, when we were discussing about how we were trying to draft, by the end of the semester, it became a challenge. And I remember we had an exam question which required you to draw a frustum. And a frustum in 3D isometric frustum would have required you to draw what we call isometric ellipses. just copied and also the same drawing from 3D and put it here for your understanding. On my right side here, what you can see is the side view from here. Okay, in this side face, it's illustrated. What you can see straight away is a hole through, a through hole. And this hole is visible when you are directly viewing from this side. But what about when it's in such a manner like this one? Let me go to the software. So I can hover over this one. It shows you that the hole is a through one through the entire block down. Okay, it highlights. That's the beauty of this software. But the question is, we are talking about an isometric. Is this a circle? Yes, it's a circle. What kind of circle? It's an isometric circle. It's oval in shape. So that's why it's called an isometric circle. And to draw it in isometrically, you've got to understand the basic principles. And today I want to walk you through the basic principles of drawing isometric circles and their applicability. And let me take you back again to our illustration. I say, in summary, isometric circles always are ellipses due to the viewing angle. Okay, let me again go back to this drawing and let me just tilt it for you understanding what I mean by the viewing angle. I can just move, I can maneuver it on that angle. I can also just rotate it. Okay, let me just maybe probably rotate it. Okay, this way. You can see directly now, you can see the angle changes. The angle changes depending on, still they're not circles. They're not the isometric circles, ellipses in this case, because the viewing angle has changed. The viewing angle has changed. The viewing angle has changed. But what if it was directly in front of you, like that one? You just see the cavity here straight away. What if it was from the other side? You'll see the hole directly as a circle, not as an ellipse. That's what I meant. So straight away into our presentation, let's move to what we call ellipses in an isometric plane. Ellipses in an isometric plane. And I believe I'm going to demonstrate what I left out by drawing the 3D object to demonstrate the cutouts later at the end of the lesson, because I know you are curious about how it's being drawn maybe in the software. It's very easy. I'll just take a few 2-3 minutes to draw that one. And also ellipses in what we call isometric plane. Let me say this is a cube. And I'd used it in the other lesson just to demonstrate on what we were just by discussing. Okay, we discussed. So ellipses lie within isometric planes of the object. What I mean by a plane, the plan is a plane. Let me go back again to the initial drawing so that you understand for those ones. I'd used a classroom the other time to demonstrate and say the floor of the class or wherever you are in a house right now, the floor of your house or your place where you live or your office is just but a plan, but it becomes a horizontal plane. Now I don't want to go deeper into planes because it will be a little bit confusing, but we'll deal that with that one when we come to orthographic views. But for now, I just wanted to understand what a plane is all about. And initially, when I started a new drawing here, there was a very good illustration of what I'm just talking about. Again, it would require me again to do this demonstration for understanding purposes. And we want to sketch it and in 2D, and when we want to sketch it in 2D, it will require me to demonstrate using this plane. So this is the XY plane. This is the what? YZ plane, and this is the XZ plane. XZ plane is like the plan, whereas the XY and the YZ, oh no, I mean the XY and the YZ can be either the front or the side face, depending on the point of view. I repeat again, depending on the point of view, you can just take this as the front face and this one also the side face, and also and either way, and vice versa. Now, having elaborated about that one, I just want to talk about a cube. In this case, quickly, I would just want to draw a cube. So at least I know, or just a rectangle. It doesn't have to be okay. Let me just say it's a cube of, let me say, 40 uh, by 40 millimeters. Okay, there it is. And I have finished sketching that one. Okay, and now I just want to extrude it so that at least it becomes what? Uh, a cube. In Inventor, we just use various tools, and in this case, I'm gonna just select this one and that one, and extrude it. Also, the other side, 40 millimeters. I will explain to you later on how to do that one, but I want to extrude it backwards. Okay, that side, and that is it. I say okay. I have just drawn the cube. Now I'll just use this cube to illustrate what I'm talking about, the faces. Okay, I'm talking about the plan now, which was the YZ, oh no, the XZ, and also the XY, and also the Y, the other side face. We don't want to go into deeper into that one. Straight away, I want to illustrate how these ellipses are being drawn. Now, the first we're gonna take now the first. Oh, where are ellipses applicable? That's the question. Pipes or chimneys and many other areas are good examples of where these ellipses are applicable. And the most important thing to pay attention to is that always make sure that the correct ellipse placement ensure accurate representation of these circular features. Now, isometrically, as you can see, the angle is 30 degrees. In 30 degrees, interiors are what? 60 degrees. Okay, as was explained there before or illustrated there before. I'll take you back so at least you don't forget my interpretation and uh, what? The angle. This is how it was. So, for example, here I've just drawn 40 height, and also 40 the depth, and it has become a cube. It's very simple and easy. But that's not the key thing here. We're just trying to understand how these ellipses are drawn. If it was just in a 2D, it just becomes and straight you're viewing it directly, it becomes just a circle. And a circle, you can just take a pair of compass and voila, you draw it. But an ellipse has to be drawn using a specific method. In this case, pay attention to the key things here. We have what we call the plane. Now we want to take the face as the profile plane in this case, okay? And this is another plane, and this is another plane. But pay attention to this, what we call the diagonals, like from the top view or face, becomes what we call the major axis, whereas the shorter axis here, the diagonal of this one becomes the minor axis. Pay attention. Okay, and also if it is from the front or the side, they change. Also, this diagonal becomes the major axis, and also the minor axis of the shorter diagonals. And I've just explained about the planes. Now we move on to something else so you understand their applicability. We want now to use, for example, the other time it was a frustum that you had done in your exam, but now today we want to basically sketching a pipe. And assuming that a pipe is drawn as such and is just a horizontal as such, let me just go straight away to my cube here. Forget about the cube, okay? And let me just draw a pipe quickly for you understanding. It would require to demonstrate what a pipe is in 3D, so you may be able to internalize quickly. Okay, here we go. Apology. Now, straight away, I would want us to draw a circle in 2D. And I'm using this plane, the YZ plane, and I'll just use a circle. And in this case, let me say it's of what? Let me say 30 or just 40, or let's say it's in millimeters. Drawing all dimensions are in millimeters. Remember that. I've just passed it as such. Okay. And now let me say it's for example, let me say 60. The outer diameter of the pipe, and let me also draw the internal one. Okay, apology for that. Let me make it at 55, assuming that the thickness would be 5 millimeter of the thickness of the pipe. Okay, the internal diameter and the interior diameter I've just drawn, and I've just finished. Now, in this case, let me go back again to the 2D, because I want to believe. I want us to draw the circle quickly. The better software, the option tool is just to extrude. Okay, I think I missed this. I think I missed this. The second internal circle. So I'm gonna select this face again, and I'm gonna just do what? And I'm gonna just draw again into the okay. This is the surface I want just to do in 2D. So I want to add the interior circle. It was 55. I missed it. Okay, what was this one? I thought I'd drawn, I don't know what it was. I can just check on the diameter. Let me check on the dimension of this one so that I'm able to understand the length. Oh, yeah. Now let me draw any other length here. Say it's that was 30. Let me say 25. And I enter. Now we have the two circles. So I finished sketching in 2D. Now we want to change into a pipe, which is isometric, and I'm going to extrude. I will select the interior, and I will, okay, I'll extrude to the back of that one. Sorry for that. Let me just give it approximately 100 millimeters long, the pipe. Okay, it's 1,000, not 1,100. Okay. Okay. Now, because it was a solid one, drawn differently. Now I'm gonna select this face. One moment, quickly. Pay attention to this. We have the outer surface and the interior part and the thickness of the pipe. Okay. Hollow pipes contain both the outer and the interior. You have just understood. Now, this one we call the ellipses, which have been sketched. And they have to be accurate. As I said again, the process of doing that one is as such. Always pay attention to manual drafting. Draw diagonals always. And as you can see, the formula is very easy. Using a French, if it's a cube, you can just use set squares, which can help you straight away just to use a 30 by 60 set square to just give you this diagonal, and you can easily, for accuracy purposes in the near future, so you don't get to miss. And at this point, you will just get to understand that always at any given, if you extend it whichever length, and if it's a cube, it has to meet because it's a face which is an ellipse. Therefore, it has always to be what fall by the diagonal. Okay, attention to that one. So upon sketching the surfaces, let's move to the next step. Now, how do we get to draw that one? Also, in the same way we did the previous one, we have to do what we call blocking. Remember, I'm going back again. I've noted. I just don't want to confuse you most of the time, but let me explain both of the two principles of the pipe and also the other drawing that we had done. And then after I've completed, I'll just go back to Inventor and I'll draw them using the blocking method we had used and subtracting it and cutouts until we have the final features for this case. In the same way as we did previously, let me take you to the process. The first step is just to create the base. Assuming the external diameter was 60, now this diameter here would be what? The length here would be 60, and the height would be 60. Now, if the length, as I said again, 100, it will be what? 100 millimeters. Hypothetical. Now, the box, you have to draw it entirely, entire box. I noted I was using a different approach, which may not work for you for now. So I need to draw a block out for you to be able to understand how to create in manual drafting an ellipse. Okay. On the first drawing the box, the next step, pay attention, is to work on this front face, this front face. Okay, remember it's just a square, and in this case it's more of a rhombus. Is it a rhombus here? No. And when it's in front of you, it's just a square, and in that case we'll have the length, which is the depth, and also the height. That's it. Now you've got to sketch the front circular opening as an ellipse. You align it. The diagonals, remember the rule, you use a 30 by 60 square, 30 by 60 square degree square. It's very easy for you while using your T-square. Now I'm talking of manual drafting because I'm explaining from a perspective of visualizing in 3D. Now, align the ellipse with the isometric plane. This is the plane. So you've got to align it very perfectly. The middle, this is the center lines, they're not perfect, but they are visible there. I'll talk about the lines later at the end of the lesson. And upon completion, you move to the next. Remember the tangents, we talked about the tangents, the two of these, and also the diagonals, the major diagonal and the minor diagonal. And I want to believe that you remember how I told you. Later, you can just join these diagonals from here to that one. For this one, along the major, to cross along the major diagonal from this point to that point with a straight edge. The point of intersection here is where you use your pair of compass with to open your pair of compass, point it at the middle of where it intersects here with a span radius from this point up to this point, and draw an arc. We'll come to that one. So the next step is to do what? Now, upon drawing that one, you identify. Now, this way I wanted to illustrate. How are you going to draw with using a pair of compass? You have to join with a straight edge from here up to that point. No. Yes. And from that perspective, at the point of intersection, open your pair of compass to span radius, this one, and draw an arc. In the same manner, on the other side, join a line from this point to this point. At the point of intersection along the major diagonal, put the point of your pair of compass here and open to a span radius of either here or there. It should be equal with this accuracy, and draw an arc. And for the shorter diagonals, you place your pair of compass from edge, start from this one, open your pair of compass to a span radius up to where the smaller arc was, and draw this longer arc. And also interchange your pair of compass to that point, and also open your pair of compass to a span radius of these, or even you never need even to change the radius, because if you are accurate, it should be the same, and then do this arc. Or manually, you can now, because we are sketching, remember we are sketching. If you were to do practically drafting, actual drafting, that's how you would have done using the right tools, pair of compass and a straight edge. But in this case, we are sketching, so you sketch a curve along that one. And that's what you call basically an ellipse using the front face. In this case, this was our front view. And we need also the internal now diameter. In the same manner, pay attention, we've just worked that one. But before this one, this has to be extended to a distance of what? 100 millimeters. So from this point, draw a straight edge parallel to this edge. And also from here, a straight edge parallel to, it's an isometric at 30 degrees actually, parallel to this base. This is how it's being drawn as such. Okay? Up to that end. From this point and from that point. Okay? And again, trace this. Remember, such as a point of symmetry can be traced. For example, at this point, you can bring about a pair of compass from this edge and that edge, and borrow this length from here, and take your pair of compass to that span radius, and also, or from this point, you can draw a parallel line. From this point, you can draw a parallel line to this one, that edge. And upon getting this length, because you don't need to draw the entire of this, pay attention to what I'm just saying. These hands-on skills. You don't need to come here and draw the same. Initially, as a beginner, you can do the same, but you can transfer this to the back end after measuring the 100 millimeters and the 100 millimeters from this point. At the point of view, At this point is where you can just draw this isometric cube or hypothetically and draw the diagonals in the same manner and also trace the same. You can easily now trace what? This curve. Okay. Now let's go to the interior and final diameter. I want to check you out, guys. Like I said again, for those who are joining and you have a question, you can just write in the chat comment section. And if you're having any challenges, please let me know. But I want to believe that you're able to view what I'm just teaching. Okay? Can you just in the chat comment let me know that you are able to view what I'm just demonstrating here? Yes. Don't chat with me, but through the chat section of the YouTube section, write your comments and write your comments. Okay. Now I'll proceed. You can raise up your questions, and I hope I'm audible enough. Okay. Okay. Let me proceed once more. Now we have come to the end of the interior diameter. In the same manner, you have to draw the box, the front hole, and you prepare the inner ellipse. So to do that one in the same way you draw the isometric box, as simple as such, also draw the diagonals and the tangents the same manner and sketch following the previous example that we've just worked. And finally, you come to an end whereby now, as usual, you've got to finalize the outer and inner cylindrical surfaces by darkening the visible edges for clarity purposes and maintaining the correct perspective and proportions. This is just para sketch. As usual, you know, I've just talked about what you're supposed to use. In this case, it's a 4H for construction lines, but a 2H, in this case, like here, you can use construction lines using a 4H, which is the hardest stencil in this case, and a 4H4 or HB for the final outline, which are darkened lines. Okay, before we go to our software to demonstrate the 3D cutouts and the rest, I want to say this, that it's equally of utmost importance to pay attention to lines and functionality. In our introduction lesson, in the onset of your first semester, we talked about lines in their applicability. But today, I would just want to focus on two basic lines, and these are the hidden lines and also the center lines. Hidden lines are just used to represent non-visible objects, okay, or hidden edges or features of an object. And how are they drawn? They're drawn using a short dashed line as such here. So the center lines are also used to indicate the point of symmetry or the centers of circles. They represent the axes of cylindrical and also symmetrical parts, drawn using long dash and short dash lines. Long dash, short dashed line in that manner. Okay, it should be a very simple freehand sketch when you're doing and using a straight edge. I demonstrated that one. During a practical lesson, I'll just do a demonstration of what you just do that one, but I've already done in your previous practical lesson. Beautiful. So pay attention always. Lines should be drawn as such because they communicate. If it's a center line, it should be drawn as a center line. And today I will do that one. Later in our lessons, I'll just illustrate about center lines and the difference between and what they're not center lines but hidden lines and also outlines in the center lines and the applicability. Yes. Now, finally, the key important information or things that you've got to understand always in drawing. And I've just talked about the paper drawings and their layouts and they are what we call borderlines, of which we've demonstrated in our basic drawing. And why the borderlines are just, but they are there just as boundary to define the boundary of your drawing. Okay, and to incubate your drawing so that they don't go outside the edges, up to the edges, even when the edges are drawn. That's the purpose of the borderline. And in most cases, and depending on the standards, depending on which kind of I don't know where you are from, American standard of mechanical engineers or whatever it is, or India, whichever country, there are both standards and also international standards, ISO standards on how you're supposed to the distance of the borderline from the edge of the paper. Like for example, this one from here to here as the right side, and also from the base, and also from the bottom, and also from the left side, etc. And the title block also is basically your ID as your student. Now the student tell me, who are you? How can I know that you're the one who drafted that work? Who is going to inspect your work? For which organization are you working as a professional outside there? And purposely, that's why the title block comes in, and in most cases, it's drawn on the lower right corner of the borderline. Lower right corner of the borderline. Yes, for that purpose, and I think I've come to the end of our demonstration before I go to the actual Autodesk Inventor to do a few demonstrations for you understanding and illustrate on the planes, among other things. I want to hear from the comment section, and if you have any other questions for me. Yeah. Once again, ensure that you've as well subscribed to our channel for future uploads. You can just get notifications of our lecture notes, etc., to enable you check them out, especially the materials that have been uploaded for your use. And start with your admission number to enable me to understand those who listened to this lesson. Now, allow me to take, I haven't seen any comment section because I expect that I want to assume I'm audible enough for you and you can hear me very well. So please write your comment there to enable me proceed once again. Okay. Now let me go straight away to Inventor. Inventor is one of the software that is used by various professionals in various fields, also including mechanical engineering and others. And it's very good, and I don't want to talk much about what it does, but for today, I just basically want to illustrate on what it does, and you can just draw about these features. I'm not going to feature Inventor in this case, but I want to illustrate the basic designs as per to our objective of today, isometric drawings. Isometric drawings, okay? And pay attention. So we started with just a block, and today I just want to maybe probably to draw the same block here for you, so that you can see and understand how it's being done, and how you can do what, and how you can do what, and how you can create the cutouts, etc., until you remain with the entire block. So I want to believe that I want to believe that you understand what an isometric drawing is. We talked about the views and the planes and etc., etc. So I'm not going to take much of your time, but go straight away to the demonstration of the block. Okay. In that case, how can you just draw if you were just in Autodesk Inventor? It's a simple search. I'll start by going straight away to a new file, and in this case let me just create a new drawing, and we'll start from scratch. Remember, we were creating a block. So in this case I'm gonna use this one to draw, or whichever way I will just use the front view in this case. And let me go just to our drawing. What did we have initially? The block. I just want to draw the block. Okay, it works as such. So I want to assume it's approximately we said 80, 100, and also the height like let me say 80, 170. Yeah. So in this case, I want an 80 by 70 the height and also the depth. So let me just go straight away to this and draw what? Let me demonstrate using a line, okay? And if that works for you, it will be easy. I would have used a rectangle method, but this one will be easy for you to understand. So we just want to say it's what? It's 70, okay, by 80. Or let me put it 100. I press enter, and I can just snap to this part. I can join to this part. I just drawn. I have just drawn it, and I just finished it. And now this is our what? Face. And I want to use this face to draw the block. In this case, I just use an extrude tool. And now, because of 100, let me make it probably towards the other direction. And it's solid. If I want, let me change it to solid. And let me make it, what's the length? Let me make it approximately 150. Yeah, it will be just a good length for us. And voila, there it is. Now, I want to maximize it for you to view the planes as we had worked earlier on. Okay, pay attention to this one. Now, what is the next thing that we needed to do? Let's check on our drawing quickly. We have this entire block now. We've just drawn the entire block. Here it is, as such. Now we want to go the first cutout. The first cutout was which one? First cutout was this one, this and that one. So, what is the length? I just want to assume that from here to here, let me take it like 20 or 30, and the rest is what? Because it was the height was 70. Yes, so let me make it 20, and the other one is for 50. Yes, so in that case, I would want you to select this face, and I want to draw on it. Okay, okay, sorry. I want just to select this face, and not extrude, but create a sketch. Okay, okay, sorry. I want to make a sketch on this one quickly. I want to take this side because it's where we are interested in, and I want maybe probably to measure a height of approximately what, draw any given length in order to do what. Okay, from this point, let me assume I can just hover over it, and over the height is approximately 70, so let me hover up to what point? We say 20, and I press enter. It locks to that place. Okay, let me just say 20, somewhere there, approximately. Okay, just let me draw a line, 20, enter, and again, what was the length? Let me just take you back to this one. What's the interior this one? Let's take it approximately 30 because it's 150. Let me put it as probably 60. Oh, no, 40 would be okay, or 30. Okay, let me put it at 40 or 50. 50 is okay, it's 150, so it's long enough. Okay, 50, and I want just to lock it there, and to lock it there, and to lock it there, and we just have finished. I've got this space, so I'm gonna just use it to cut out the surface. Now, in that case, I'm gonna do what? Select extrude, and in this case, I'm gonna cut through this backward, the other opposite side, and I say cut through, go through, and I say okay. We have remained with the other now. That's the first cutout. Now, the second cutout was on the side. Let me just take you back to the drawing, the lower, the second shape was that was the first part. The second part was this cutout, the lower cutout. We want to assume that maybe the depth of this towards that one is approximately smaller. You can see it's not up to the end, but partially that much. Let me say we've used 50, so let's take it at 20 interior and cut it down the entire part of it. So you want to understand how we're going to cut this one. In that case, we take this surface and draw it. So okay, this I will select this surface and I want it to okay, it has a center. Okay, so if it's at the center, there's something I want to show you. The tricks of just drawing. That's the difference now in manual drafting and also software drawing. So quickly, I can just want to sketch this surface. I want to hover. First of all, I want just to draw a circle. And if I've just said, let it be what? I just hover and it will snap to the center. As you can see, it snap to the center. This was 100. So let me make this one, let me say the diameter 40. So at least we can have approximately, oh yes, diameter 40, 2020, both sides. And I'll just draw that circle. Now at this edge, I'll just use what we call a straight edge at this point to draw what? And give it, because I talked about 20 depth, just draw that one and downwards, okay, up to that extent. I will hover and join it up to that point and also to that point, that much, and also back to that point, and escape. And I will now delete the circle. It was just a guideline. It's given me this length is at the center, from the center of this part to this part, at a point distance of a diameter 40, which means from the center to here is 2020, and the interior is 20 millimeters. Before I dimension it, I'll just over later, but for now, I have finished drawing. Okay, that's it. Now I will just again cut that part by using an extrude tool. I'll select that one, and also now I'll cut through downwards, opposite direction downwards, and I'll cut through, and that's it. Well, beautiful. Now what's the next step? I can just decide to edit this side so it can be smaller, but I'm not interested. It's this side. And now we want to, the third part was to go to what? The last cutout, this cutout surface. Okay, this cutout surface. We want to assume, hypothetically, it's cut at a given distance from this edge and a given distance from that edge. So straight away, what we just do is take this surface. You can use this surface. Okay, I can just use this surface to sketch and use it to draw. Let me zoom so it's visible to you. Okay, and there we are. It is this corner that was cut. So that kind of cutting, we call it a chamfer, chamfering the angle. These are for today. I don't want just to go into the role of inventor, but I just want to show you manually how you would have just done. You would have measured now the given distance. If it were given, say it was up to that point from the midpoint, hypothetically, okay, or just a small portion, or from a given point here, it was let me say, because it was what 100, let me say 40 millimeters, okay, and okay, 40 millimeters. So let me just draw another. Oh, sorry, I just do that one, 40 millimeters, and I'll just from there again, I'll just sorry, and let me draw another line from here up to there. Another one of 40 millimeters down height, or just maybe probably 30. Okay, and I will just join another line up to that extent, which is 40 millimeters. We have completed, and I just say finish. And now we want to take away, cut out that section, what we call a chamfer. Now I want to use again the extrude tool. In this case, I'll just in the opposite direction, and I'll cut through that direction, and I'll just say okay. And there is our design. So basically, you remember very well when we're doing this part, I can always edit this part. Okay, just go back to the edit section, and instead of 100, I can just maybe double click there and give it what? To give it a shape, maybe give it at 100 is too big, so 150 is too large, and I just say finish. That one I would have completed it, and that's it. Now, as you can see, in the same manner, we have completed our drawing. As simple as such, it's almost the same as this one because it was never to scale. So if you were to scale, it would be something like that. The cutters have been done. Next time, I'll just show you on how we can extrude and create some plans from this and views in orthographic views later in our discussion as we proceed further. Okay, to give you just a tip, maybe here you've just seen it. It had the initial one had some what you call color. Remember, the software can allow you just to see the material well in the same way, assuming it was whichever material it was. Here it's generic, so you can just go to what you call the material instead of the generic. You can just maybe call it what do you want to call it? What is it? Assume let's assume it's glass. Okay, that's how it can be reflected. Okay, it's clear. What if it was a metal? And which kind of metal is it? Uh, let's talk about aluminium. Aluminium is a good one. Or copper. No, let me just talk about aluminium. Which kind of aluminium? The aluminium welder. Let's check it out. Okay, that's it. What about we check about other materials? Stainless steel or steel alloy. If we change it, we can just see the shape and also by default what it is. And let me try to turn around and over it, etc., 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 etc. Now, basically, that's it for today, and we call it the end of our lesson. Now, let me just go to another questions. If you have another questions, we can just respond to your questions right away. Are there any other questions? If there are no other questions, we shall proceed again further into our discussion for today. Have a lovely morning and a good day, and thank you for your time.